Eddie Sullivan's hands were trembling as he stared at the voltage meter, the needle dancing erratically between safe and catastrophic levels. Deep in the bowels of the USS Hornet, nobody else seemed to notice what he was seeing, this tiny anomaly that kept him awake at night. He'd tried telling his superiors 3 times already, but they dismissed it as routine fluctuation. Then came that morning in June 1943 when the elevator system on Deck 4 started smoking during a routine aircraft transfer, and Eddie realized his worst fear was about to come true. What he didn't know was that his homemade solution, cobbled together from spare parts in a cramped workshop, would become the difference between victory and disaster for the entire Pacific Fleet. He didn't know that admirals would soon be studying his design, that his name would be whispered in Navy engineering circles for decades, or that the tiny coil of copper wire he wound by hand would save thousands of lives. But as sparks began flying from the elevator, housing that humid morning, one question burned in his mind. Would anyone listen to a lowly electrician's mate before it was too late? Before we carry on, please hit the subscribe button to make my day, and let me know where you are watching from in the comments. The fluorescent lights in the carrier's electrical room cast harsh shadows across Eddie Sullivan's weathered face as he hunched over his workbench at 0300 hours. Most of the crew was asleep, their hammocks swaying gently with the Pacific swells. But sleep had become a luxury Eddie couldn't afford. For the past 6 weeks, ever since the Hornet had departed Pearl Harbor for its latest deployment, he'd been tracking an electrical problem that nobody else seemed to believe existed. The voltage surges were subtle, lasting only fractions of a second, but they appeared with disturbing regularity in the carrier's massive elevator systems, the hydraulic platforms that lifted fully loaded aircraft from the hangar deck to the flight deck above. Eddie had joined the Navy in 1941, just 3 months before Pearl Harbor turned the world upside down. He'd been working as an electrician in a small town in Ohio, fixing residential wiring and installing lighting fixtures for modest homes, when the recruiting officer came through town with promises of adventure and serving his country. At 24 years old, Eddie had never seen the ocean, never imagined he'd end up responsible for maintaining the electrical systems on one of America's most vital warships. His wife Margaret had cried when he enlisted, clutching their infant daughter Anna close to her chest, but she understood that some things were bigger than fear. The letters she sent him, which arrived in irregular bundles whenever the mail ship caught up with the fleet, were his lifeline to sanity. The problem Eddie had discovered wasn't the kind of dramatic failure that would make officers pay attention. It wasn't sparks shooting across the deck or circuits exploding in showers of flame. Instead, it was insidious, a creeping instability in the power delivery system that fed the elevator motors. Every time one of the massive platforms lifted a Dauntless dive bomber or a Wildcat fighter from the hangar to the flight deck, the electrical demand spiked dramatically. The ship's generators were designed to handle these surges, but Eddie's meticulous measurements revealed that the voltage wasn't stabilizing properly afterward. The needle on his meter would spike high, then overcorrect low, then oscillate wildly for several seconds before settling. Each time it happened, the electrical insulation on the motor windings got a little hotter, degraded a little faster, crept a little closer to catastrophic failure. He'd brought his concerns to Chief Petty Officer Raymond Kowalski 3 separate times. Kowalski was a career Navy man, 22 years of service, with the kind of confidence that came from having seen everything twice. The first time Eddie approached him, Kowalski had barely looked up from his coffee. "Sullivan, those generators have been running since this ship was commissioned. If there was a problem, the designers would have caught it." The second time, Kowalski was more irritated. "I've got 50 maintenance requests backed up, son. Unless you've got smoke or sparks, it ain't priority." The third time, Eddie brought his carefully compiled data, graphs he'd drawn by hand, showing the voltage patterns over 2 weeks of measurements. Kowalski had studied the papers for maybe 30 seconds before handing them back. "Looks like normal variation to me. These ships aren't precision instruments, Sullivan. They're floating cities built for war." Some wobble in the power as expected. But Eddie couldn't shake the feeling that everyone was missing something crucial. He'd grown up watching his father, also an electrician, approach every job with meticulous attention to detail. Frank Sullivan had taught his son that the most dangerous electrical problems were the ones you couldn't see, the slow degradations that gave no warning before they failed catastrophically. Electricity doesn't forgive carelessness, his father used to say while they worked together in their garage workshop. It's patient, but when it decides to bite, it bites hard. Those words echoed in Eddie's mind every time he took another reading from the elevator systems. The USS Hornet was a massive vessel, over 800 feet long and capable of carrying more than 80 aircraft. Its crew of nearly 3,000 men worked around the clock to keep it operational, a floating fortress that served as a critical launch platform for strikes against Japanese forces across the Pacific. The carrier's 4 elevator platforms were engineering marvels, capable of lifting aircraft weighing several tons from the protected hangar deck to the exposed flight deck in less than 30 seconds. The speed was necessary because during combat operations, every second counted. Pilots needed to launch quickly, and damaged aircraft returning from missions needed to be cleared from the deck immediately to make room for the next wave. Any delay, any mechanical failure, could mean the difference between mission success and disaster. Eddie's workshop was tucked into a narrow compartment just aft of the number 2 elevator shaft. The space was barely large enough for his workbench, a few shelves of spare parts, and the collection of tools he'd acquired through careful tradings with other crew members. The constant vibration from the ship's engines made detailed work challenging, and the tropical heat meant he was always covered in sweat. But Eddie had learned to make do. In his spare moments, when he wasn't standing watch or performing routine maintenance, he studied electrical engineering textbooks he had borrowed from the ship's tiny library. He was particularly fascinated by a concept called harmonic resonance, the way electrical systems could develop oscillations that fed back on themselves, growing stronger with each cycle until something gave way. It was during one of these late-night study sessions that Eddie had his breakthrough. He was reading about power factor correction in industrial systems when he realized that the elevator motor's inductive load was creating exactly the kind of resonance problem the textbook described. Every time a motor started, it drew a massive surge of current that lagged behind the voltage due to the magnetic fields in the motor windings. The ship's generators tried to compensate, but they were overcorrecting, creating a feedback loop that manifested as the voltage oscillations Eddie had been measuring. The solution, according to the textbook, was to install a capacitive load that would counteract the inductive effects, stabilizing the power delivery and preventing the oscillations. The problem was that Eddie had no authority to modify the ship's electrical systems, especially not based on a theory he'd developed from a textbook, while the Navy's own engineers insisted everything was fine. But he also couldn't ignore what he knew. The USS Hornet was scheduled to participate in a major operation in less than 2 months, one that would require intensive flight operations with aircraft launching and recovering almost continuously for days. If Eddie's calculations were correct, the stress on the elevator systems during that operation would push them past their breaking point. A catastrophic failure during combat operations could leave the carrier unable to launch or recover aircraft, effectively removing it from the battle. Worse, an electrical fire in the confined spaces of the hangar deck could spread rapidly, potentially destroying the entire ship. Eddie made a decision that would either save lives or end his Navy career. He would build a prototype stabilizer using spare parts and install it on the number 2 elevator system without official authorization. If it worked, he'd have proof that the problem was real and the solution was viable. If it didn't work, or if he got caught before he could demonstrate its effectiveness, he'd likely face disciplinary action for tampering with critical ship systems. The risks seemed worth it, especially when he thought about Margaret and Anna back home, depending on him to do whatever was necessary to end this war and come home safely. The stabilizer coil Eddie designed was deceptively simple. He wound copper wire around an iron core salvaged from a burned-out transformer, creating an inductor that could store and release electrical energy in precise timing with the elevator motor cycles. He paired this with capacitors he requisitioned under the guise of replacing failed components in other systems, assembling them into a circuit that would smooth out the voltage spikes and prevent the dangerous oscillations. The entire assembly fit into a housing no bigger than a shoebox, something that could be installed in the elevator's control panel without extensive modifications. Eddie worked on it for 3 weeks, winding the copper coil by hand during his off hours, calculating and recalculating the values to ensure the components would handle the voltage and current levels without failing. The installation happened during a scheduled maintenance period when the number 2 elevator was already offline for routine inspection. Eddie waited until the maintenance crew had finished their work and logged off for chow, then slipped into the control room with his stabilizer coil hidden in a tool bag. His hands shook slightly as he opened the main electrical panel, the one covered in warning labels about high voltage and authorized personnel only. Inside was a maze of wires, circuit breakers, and junction blocks, all labeled with cryptic codes that meant nothing to anyone except the electricians who maintained them. Eddie had memorized the layout weeks ago, studying the technical drawings until he could navigate the panel blindfolded. He found the connection point he needed, a junction where the power feed from the ship's main bus entered the elevator motor control system. Working quickly but carefully, he disconnected 2 of the existing wires, inserted his stabilizer coil into the circuit, and secured everything with electrical tape and tie wraps. The modification looked almost professional, clean enough that it might be mistaken for original equipment if nobody looked too closely. Eddie closed the panel, restored power to the elevator, and held his breath while the system ran through its automatic diagnostic cycle. Green lights appeared across the control board, indicating normal operation. So far, so good. Over the next several days, Eddie monitored the number 2 elevator obsessively. He took voltage readings during every lift cycle, compared them to the readings from the other 3 elevators, and documented everything in a notebook he kept hidden in his locker. The results were undeniable. The modified elevator showed rock-solid voltage stability, the kind of clean power delivery that the textbooks described, but Eddie had never seen in practice on the ship. Meanwhile, elevators 1, 3, and 4 continued showing the same erratic patterns Eddie had been tracking for months. The stabilizer coil was working exactly as he'd hoped, but he still needed to convince someone in authority to pay attention. His opportunity came in early June, when Commander Patricia Reynolds arrived aboard the Hornet as part of an engineering assessment team from Pearl Harbor. Reynolds was one of the Navy's few female engineering officers, a graduate of MIT who joined the service in 1941, with expertise in electrical systems and power distribution. Her presence on a combat vessel was unusual enough to generate gossip throughout the crew, but Reynolds seemed unbothered by the attention. She spent her days touring the ship with a clipboard, asking detailed technical questions that revealed a depth of knowledge that impressed even the most skeptical chiefs. Eddie saw his chance and decided to take it. He approached Commander Reynolds in the passageway outside the forward elevator machinery room, catching her between inspection stops. "Excuse me, Commander. Electrician's mate Sullivan. I wonder if I could have a moment of your time regarding the elevator power systems." Reynolds paused, her sharp eyes taking in Eddie's nervous posture and the notebook clutched in his hands. "What about them, Sullivan?" Her tone was neutral, neither encouraging nor dismissive. Eddie launched into his explanation, starting with the voltage oscillations he'd discovered, the potential consequences he'd calculated, and the unauthorized modification he'd made to the number 2 elevator. He spoke rapidly, aware that he might only have this one chance to make his case before she dismissed him or reported him for tampering with ship systems. To Eddie's surprise, Reynolds didn't interrupt. She listened carefully, occasionally asking clarifying questions that demonstrated she understood the technical details of what he was describing. When Eddie finished, she was quiet for a moment, clearly thinking. "Show me your data," she finally said. "All of it, and I want to see this stabilizer coil you installed." Eddie's heart raced as he led her to his workshop, produced his notebooks full of voltage measurements and hand-drawn graphs, and retrieved the spare stabilizer coil he'd built as a backup. Reynolds examined everything with the kind of methodical attention that made Eddie think maybe, just maybe, someone was finally taking him seriously. Reynolds spent the next 2 hours testing the modified elevator system herself, taking measurements with precision equipment she'd brought from Pearl Harbor. She compared the performance of the modified number 2 elevator against the unmodified systems, ran the elevators through stress tests that simulated combat operation conditions, and consulted technical references she pulled from her briefcase. Eddie stood by anxiously, answering questions when asked, but mostly trying to stay out of the way. Finally, as the tropical sun was setting and casting orange light through the porthole, Reynolds turned to him with an expression Eddie couldn't quite read. "Sullivan, what you've discovered is significant. More significant than you probably realize. This isn't just a Hornet problem. If the voltage instability you identified exists on this carrier, It likely exists on every carrier in the fleet because they all use similar electrical systems. The implications of Reynolds' statement hit Eddie like a physical blow. He'd been so focused on the Hornet that he hadn't considered the possibility that his discovery might apply to the entire carrier fleet. If that was true, then the danger was far more widespread than he'd imagined. Reynolds continued, "The unauthorized modification is a problem we'll need to address, but right now, that's secondary to preventing potential disasters across the fleet. I'm going to recommend that the Bureau of Ships conduct immediate inspections of all carriers' elevator systems and expedite production of stabilizer units based on your design. But, Sullivan, I need you to understand something. If your analysis is wrong, if this problem isn't as serious as you believe, this could damage both our careers. Are you certain about what you found?" Eddie met her eyes without hesitation. "Commander, I've triple-checked every measurement, verified every calculation. The problem is real, and without intervention, it's going to cause catastrophic failures. I'd stake my career on it because I already have." Reynolds nodded slowly, a hint of a smile crossing her face. "Then I guess we're both betting on your copper coil, Sullivan. Let's hope you're right." The next several weeks were a blur of activity. Reynolds filed her report with Pacific Fleet Command, and within days, engineering teams were dispatched to every carrier in the theater to assess their elevator electrical systems. The results confirmed Eddie's findings. Every carrier showed the same voltage instability patterns, and several were found to have motor insulation that was already significantly degraded, teetering on the edge of failure. The Navy moved with unusual speed to address the problem, recognizing that the entire carrier fleet was potentially vulnerable. Eddie found himself reassigned to temporary duty at Pearl Harbor, working with a team of engineers to refine his stabilizer coil design for mass production. The Pearl Harbor Navy Yard was a sprawling complex of dry docks, repair facilities, and workshops, still bearing scars from the Japanese attack 19 months earlier. Eddie was given a small office in the electrical engineering building, a luxury compared to his cramped workshop on the Hornet. He worked alongside civilian engineers and Navy technical specialists, translating his handmade prototype into specifications that could be manufactured by the thousands. The process was humbling and educational. The engineers immediately saw ways to improve his design, substituting better materials and optimizing the coil geometry to achieve more stable performance across a wider range of operating conditions. But they also respected the fundamental insight Eddie had provided, the recognition that carrier elevator systems had an inherent electrical instability that needed correction. Commander Reynolds became Eddie's advocate and mentor, running interference with the bureaucracy and ensuring he received credit for his discovery. She explained to him that the Navy was a rigid hierarchy, but it was also pragmatic. When someone from the lower ranks solved a problem that the brass had missed, the service had two choices: suppress the embarrassment or embrace the solution. Fortunately, with a war on and lives at stake, the Navy chose the latter. Eddie was promoted to Petty Officer Second Class and received a commendation for his work, though the citation was carefully worded to downplay the unauthorized modification that had started everything. "They're willing to forgive your initiative once they see the results," Reynolds told him with a wry smile. "Just don't make a habit of modifying ship systems without permission." In late July, testing of the production stabilizer units began. 50 units were manufactured and installed across 3 carriers: the Hornet, the Enterprise, and the newly commissioned Essex. The results were immediately apparent. Voltage stability improved dramatically, motor operating temperatures dropped by an average of 15 degrees, and the dangerous oscillations that had concerned Eddie disappeared completely. More importantly, engineering projections suggested that the stabilizers would extend the operational life of elevator motor systems by 30 to 40%, saving the Navy millions of dollars in replacement costs and reducing the risk of in-service failures. The Bureau of Ships approved full-scale production and mandated installation on every fleet carrier by the end of 1944. Eddie returned to the Hornet in August, just in time for the carrier to participate in operations against Japanese-held islands in the Central Pacific. The tempo of flight operations was intense, with aircraft launching and recovering almost continuously during daylight hours. The elevator systems, now equipped with stabilizer coils on all 4 platforms, performed flawlessly despite being pushed harder than ever before. Eddie watched from his station in the electrical room, monitoring the voltage readings that remained steady and clean even during the most demanding operations. It was a strange feeling, knowing that the tiny modification he'd built in secret was now standard equipment protecting not just his ship, but the entire carrier fleet. But the true test of Eddie's invention came on a humid morning in September during strikes against Japanese positions on Marcus Island. The Hornet had been launching aircraft since dawn, her deck crew working with practiced efficiency to keep planes moving from hangar to flight deck and back again. Eddie was on duty in the electrical room, his usual station, when one of the junior electricians burst through the hatch with panic in his eyes. "Sullivan, you gotta see this. Number 3 elevator, something's burning." Eddie grabbed his tool bag and raced through the ship's passageways, following the acrid smell of electrical smoke. When he reached the number 3 elevator machinery room, he found a small crowd of maintenance personnel staring at the motor control panel, where wisps of smoke were escaping from a junction box. Eddie pushed through the crowd and opened the smoking junction box, immediately identifying the problem. A power cable had been damaged, probably by vibration or improper installation, and had finally shorted against the metal enclosure. The resulting arc had begun to melt the insulation on adjacent wires, creating the smoke that had drawn everyone's attention. If the short had occurred on any of the carriers before the stabilizer coils were installed, the voltage oscillations would have fed additional energy into the arc, causing it to grow rapidly until it became a full-scale electrical fire. Eddie had seen exactly this scenario in his calculations, one of the potential failure modes that had driven his initial concern. But as he examined the damage, he realized something remarkable. The stabilizer coil had limited the energy available to the arc, preventing it from escalating beyond a minor short circuit. The circuit breaker had tripped exactly as designed, isolating the fault before it could spread. Eddie worked quickly to repair the damaged cable and replace the burned components. The entire repair took less than 30 minutes, and the number 3 elevator was back in service before the next wave of aircraft was ready to launch. It was a minor incident, barely worth mentioning in the ship's log, but Eddie understood its significance. Without the stabilizer coil, that small short circuit could have become a major fire in one of the most dangerous locations on the ship. The hangar deck was always stocked with aircraft, aviation fuel, ammunition, and bombs. A fire there could spread rapidly, potentially destroying the entire carrier and killing hundreds or thousands of men. Eddie's tiny spark of insight, his homemade coil of copper wire, had quite possibly saved the USS Hornet and her crew. Word of the incident spread through the engineering spaces, and Eddie found himself fielding questions from other electricians who wanted to understand how the stabilizer had prevented a worse outcome. He explained the technical details as best he could, but he also emphasized the broader lesson his father had taught him years ago. Electrical problems don't announce themselves with obvious symptoms until it's too late. The key to safety was identifying and addressing subtle anomalies before they became catastrophes. It was a philosophy that was starting to gain traction throughout the Navy's electrical maintenance community, changing how electricians approach their jobs on ships across the fleet. Commander Reynolds sent Eddie a letter congratulating him on the successful emergency response and informing him that the Bureau of Ships was documenting the Marcus Island incident as a case study in how the stabilizer coils prevented catastrophic failures. The letter also included news that Reynolds had been promoted to the rank of captain and assigned to oversee electrical engineering standards for the entire Pacific Fleet. "Your copper coil is going to outlive both of us, Sullivan," she wrote. "Every carrier launched from now until the end of this war will have your design built in from the start. You should be proud of what you've accomplished. But don't let it go to your head. The Navy has plenty of other problems that need solving, and I expect you to keep your eyes open for the next one." As 1943 turned into 1944, Eddie settled into a routine aboard the Hornet. He stood his watches, maintained his electrical systems, and continued taking meticulous measurements of ship performance. He also found time to correspond regularly with Margaret, who wrote about life back home in Ohio, about their daughter Anna's first words and first steps, about the victory gardens and rationing, and the way everyone in town was contributing to the war effort in their own small ways. Margaret's letters reminded Eddie why he was out here, fighting a war thousands of miles from home. It wasn't abstract patriotism or political ideology. It was about making sure Anna would grow up in a world where she could live safely, where she wouldn't have to fear invasion or occupation or the horrors that war brought. The war in the Pacific ground, on through 1944, with brutal intensity. The carrier fleet, including the Hornet, participated in major operations from the Marshall Islands to the Marianas, from the Philippines to Iwo Jima. Through it all, the stabilizer coils that Eddie had designed continued to perform exactly as intended, preventing the kind of electrical failures that would have crippled the fleet at critical moments. Navy engineers estimated that the coils prevented at least 36 serious incidents during 1944 alone, incidents that could have resulted in fires, equipment damage, or worse. Eddie received another commendation and was promoted to Petty Officer First Class, but the recognition that meant the most to him came from his fellow electricians, the men who worked alongside him in the ship's electrical spaces and understood what he'd accomplished. In April 1945, as the war in Europe was reaching its conclusion and the Pacific Campaign was entering its final, bloody phase, Eddie received orders transferring him back to the United States. His tour of duty was complete, and the Navy was rotating combat veterans home to help train the next generation of sailors. Eddie felt conflicted about leaving. The Hornet had been his home for nearly 3 years, and he'd formed deep bonds with the men he'd served alongside. But he also desperately wanted to see Margaret and Anna, to hold them close and rebuild the life that war had interrupted. On his last day aboard, Chief Kowalski, the man who'd dismissed Eddie's concerns about voltage surges so many times, pulled him aside for a private conversation. "Sullivan, I owe you an apology," Kowalski said, his weathered face serious. "When you first came to me about those voltage readings, I should have listened. I was too focused on the urgent problems right in front of me to pay attention to what you were seeing. You were right, and your persistence probably saved this ship and a lot of others. That took guts, kid, especially going ahead with that modification when nobody would back you up. The Navy needs more sailors like you, ones who won't ignore a problem just because it's inconvenient or doesn't fit what we expect." Eddie shook the chief's offered hand, feeling a sense of closure. "I just did what needed doing, Chief. Same as everyone else out here." Eddie's homecoming was everything he'd dreamed about during long nights in the Pacific. Margaret met him at the train station in Ohio with 3-year-old Anna, who was shy at first around this stranger in a uniform, but gradually warmed up to the father she barely remembered. They moved into a small house that Margaret had found during his absence, and Eddie took a job with the local power company, using his Navy training and experience to work on civilian electrical systems. Life slowly returned to something resembling normal, though Eddie carried the war with him in ways that Margaret could see even when he didn't speak about it. He would wake sometimes in the night, checking imaginary voltage meters, or freeze when he heard certain sounds that reminded him of the ship. But Eddie also carried something else from his Navy service, a sense of confidence in his own judgment, and an understanding of how much one person could accomplish when they refused to ignore a problem. He became active in the local Electricians Union, advocating for better safety standards and more rigorous training programs. He taught night classes at the community college, passing on the lessons he'd learned about electrical systems and the importance of paying attention to subtle anomalies. And he told his story, carefully and without boasting, to young electricians who needed to understand that their work mattered, that attention to detail could make the difference between safety and disaster. The Navy didn't forget Eddie Sullivan or his contribution. In 1946, after the war had ended, and the fleet was being reduced to peacetime levels, the Bureau of Ships published a comprehensive report on carrier electrical systems that devoted an entire chapter to the stabilizer coil design and its impact on fleet operations. The report credited Eddie by name and included detailed technical drawings of his original handmade prototype, which had been preserved as a teaching tool at the Navy's electrical training school. Commander Reynolds, now a rear admiral, wrote the report's foreword, emphasizing that the best innovations often came from enlisted personnel who worked directly with equipment and understood its quirks and limitations better than distant designers and engineers. Eddie learned about the report from a letter that arrived one autumn morning, forwarded from the Navy with Admiral Reynolds' compliments. Inside was a copy of the report and a personal note from Reynolds. "Sullivan, your coil is still saving lives. We've had no major electrical failures on carrier elevators since the stabilizers were installed fleet-wide, and the design is now being adapted for other applications throughout the Navy. You should know that you changed not just the technology, but also the culture. We're encouraging sailors at all levels to report anomalies and propose solutions, even when those solutions challenge conventional wisdom. You started something important, and I wanted to make sure you knew it. Fair winds and following seas. Eddie sat in his kitchen, reading Reynolds' letter, while Anna played with toy blocks on the floor and Margaret prepared dinner. He thought about the night in his cramped workshop aboard the Hornet, winding copper wire around an iron core while the rest of the ship slept, uncertain if anyone would ever listen to his concerns. He thought about the moment he decided to install the stabilizer without authorization, betting his career on a theory drawn from textbooks and careful observation. And he thought about the smoke rising from the number 3 elevator junction box, the fire that never was, because a tiny coil of copper wire had done exactly what it was designed to do. It was strange how something so small, something that fit in a shoebox and cost maybe $20 in parts, had rippled out to affect thousands of lives and change the course of the war in ways most people would never know about. Margaret noticed him lost in thought and came over, reading concern in his expression. "Everything okay?" she asked gently. Eddie folded the letter and smiled at his wife, at his daughter, at the life they were building together in peacetime. "Yeah," he said. "Everything's fine. Just thinking about the war, about how you never know which small actions are going to matter. I made something once, just a tiny fix really, and it turned out to be more important than I ever imagined." Margaret squeezed his shoulder, understanding without needing details. "That's my Eddie, always seeing things other people miss. That's why I married you." Eddie pulled her close, grateful beyond words for this second chance, this opportunity to grow old with the woman he loved and watch his daughter become whoever she was meant to be. In the decades that followed, Eddie's stabilizer coil design continued to evolve and find new applications. The Navy adapted it for use in submarine electrical systems, in destroyer power distribution networks, and eventually in the nuclear carriers that began joining the fleet in the late 1950s. Private industry took notice as well, and variations of Eddie's basic design showed up in industrial power systems, manufacturing equipment, and even early computer installations that required extremely stable electrical power. Eddie followed these developments with quiet satisfaction, occasionally consulting for companies that wanted to understand the underlying principles of his invention. He never sought patents or financial compensation, feeling that his contribution had been part of his service to the country and shouldn't be commercialized for personal gain. But perhaps Eddie's greatest legacy was the example he set for generations of electricians and engineers who came after him. His story became part of Navy training curriculum, taught to every electrician's mate who went through technical school. Instructors used his experience to illustrate important lessons about the value of careful observation, the courage required to challenge authority when safety was at stake, and the way that expertise developed from hands-on experience could be just as valuable as formal engineering education. "Be like Sullivan" became informal shorthand in Navy electrical shops, meaning pay attention to details, document your findings, and don't ignore problems just because they're inconvenient or unpopular to raise. Eddie lived to see the end of the Cold War, the transformation of the Navy into a global force built around carrier battle groups that dominated the oceans, and the advent of technologies he could never have imagined during his days aboard the Hornet. He watched with pride as Anna grew up, went to college, became an engineer herself, carrying forward the family tradition of working with electrical systems and solving technical problems. In his final years, living in a small retirement community in Florida, Eddie would occasionally get visitors, young Navy electricians who'd read about him in their training materials and wanted to meet the man behind the legend. He always welcomed them, sharing stories and wisdom and emphasizing that he'd been nothing special, just a sailor who paid attention and did what needed doing. Eddie Sullivan passed away peacefully in 2003 at the age of 86, surrounded by family and with a lifetime of service and accomplishment behind him. His obituary in the local paper mentioned his Navy service and his years working for the power company, but it didn't capture the full scope of what he'd achieved or the lives he'd saved. That knowledge lived in Navy archives, in technical reports, and in the institutional memory of the service he'd served so well. At his funeral, a Navy honor guard presented Margaret with a folded flag, and a captain who'd come down from Norfolk gave a brief eulogy that touched on Eddie's contribution to carrier safety and fleet operations. Petty Officer Sullivan represented the best of what the Navy can be, the captain said. He saw a problem, he solved it, and he did it with humility and dedication to his shipmates. The fleet is safer today because of his service, and we will not forget him. Margaret kept the letter from Admiral Reynolds in a frame on her mantel, along with Eddie's service medals and a photograph of him in his Navy uniform, taken aboard the Hornet in 1943. Sometimes, when her grandchildren visited, they'd ask about Grandpa and his time in the war. Margaret would tell them the story of the copper coil, of how Eddie had refused to ignore something that everyone else dismissed, of how his tiny fix had changed the fate of the Pacific Fleet. The grandchildren would listen with wide eyes, struggling to connect this heroic story with their memories of a gentle old man who liked to tinker in his garage workshop and always had candy in his pockets. But Margaret understood that both versions of Eddie were true, that heroes were just ordinary people who did extraordinary things when circumstances required it. The stabilizer coils that Eddie designed, now many generations refined and updated, still protect electrical systems on every carrier in the United States Navy. Modern versions use solid-state electronics instead of copper windings, digital controls instead of passive components. But the fundamental principle remains the same. Actively stabilize the power delivery to prevent dangerous oscillations and protect critical equipment. Navy electrical engineers still study the original design as part of their training, learning from the elegant simplicity of Eddie's solution and the way he identified a problem that more experienced personnel had missed. In that sense, Eddie Sullivan never really left the service. His insight, his innovation, his stubborn refusal to ignore what he knew to be true, all of it continues to protect sailors and ships decades after his death. There are no monuments to Eddie Sullivan, no ships bearing his name, no public recognition of his contribution beyond the small circle of people who work with Navy electrical systems. But perhaps that's appropriate. Eddie never sought glory or fame. He wanted to do his job well, protect his shipmates, and get home safely to his family. The copper coil was never about personal advancement or legacy. It was about solving a problem that needed solving, about preventing a disaster that he could see coming when nobody else was looking in the right direction. In the end, that might be the most important lesson from Eddie's story, that real heroism often looks like ordinary work, that the most significant contributions are sometimes made by people nobody remembers, and that tiny sparks, properly directed, can change the course of history. Today, if you visit the National Naval Aviation Museum in Pensacola, Florida, you can find a small display case in the Carrier Technology section. Inside is a battered copper coil wrapped around an iron core, accompanied by a placard that reads, "Voltage Stabilizer Coil, Original Prototype, designed by Petty Officer First Class Edward Sullivan, USS Hornet, 1943. This device revolutionized carrier electrical systems and prevented numerous casualties during World War II and beyond. The display gets less attention than the gleaming aircraft and dramatic battle dioramas that surround it. Most visitors walk past without a second glance, drawn to more visually impressive exhibits. But occasionally someone will stop and read the placard, will study the simple coil of copper wire, and will understand that sometimes the smallest things make the biggest difference. That's when Eddie Sullivan's legacy lives again, in that moment of recognition, in the understanding that passes between one generation and the next, in the knowledge that ordinary people can accomplish extraordinary things when they refuse to look away from problems that need solving. And somewhere, in the electrical spaces of carriers patrolling distant oceans, Eddie's tiny spark continues to burn bright, protecting sailors who will never know his name but owe him their lives.